Hello everyone, welcome back to my channel. I hope everyone is doing great. Let's solve today's Leetcode problem 2048. Next greater numerically balanced number. An integer x is numerically balanced if every digit d in the number there are exactly d occurrences of that integer of the digit in x. Okay. Given an integer n, return the smallest numerically balanced number strictly greater than n. Okay, so here we have been given n is equal to 1. So we have to identify the first number which is strictly greater than 1, and all the digits in that particular number has to appear exactly d occurrences. Okay, if a particular digit d exists in that number, then that means it has to appear exactly d times. Okay, so here there is only one digit d which is equal to 2, and it has to appear 2 times. Okay, so that's the reason this is balanced number. If you see this, there are 2 digits which are actually occurring in the number. It is 1 and 3, and 1 appears 3 times and 3 also appear 3 times. Okay, this is, we should also take care that 0, I think 0 should not appear. Okay, if you see here in this example, n is 3000. Okay, but we are looking for strictly numbers which are strictly greater than 3000. Okay, if n is 2999, okay, then the is 3000 a valid number? No, it's not, because 0 should not appear in the number itself. Okay, every digit d has to appear exactly d times. Okay, yeah, let's look at the solution. Because the constraints are very constraints, if you see, look at the constraints, n is going all the way up to 10 power 6. Okay, we can simply implement the brute force approach. That will actually work here, because for each number we are actually checking all the digits in the number. Okay, so that will be like, we can identify that in the constant time itself. So the overall time complexity will be order of n. Okay, to be frank, it will be order of n minus the number of digits, which we will start from n plus 1 and go all the way up to this particular number. Why all the way up to this particular number? The reason being, this is the first balanced number after 10 power 6. Okay, 10 power 6 contains 6 zeros, and after, you can actually see this could be the smallest number. Okay, 3 cannot, if 3 appears 3 times, okay, then there will be one decimal which we can't fill with any other digit. So this is actually the first smallest balanced number after 10 power 6. Okay, so we'll start at n plus 1. Reason being, they ask the strictly greater than number, so we'll start at n plus 1 and go all the way up to this and check whether a particular number is balanced or not. Okay, so what I have done is I've identified the frequency of the digits in the given number. Okay, for each number I'm checking how many times a particular digit occurs. Okay, and if a particular digit exists in the given number, then its frequency should be equal to its digit. Okay, if any of this condition, if this condition is failing, that means it's not a balanced number or it's not a beautiful number, so we'll return false. If all the digits satisfy this condition, that means it's a balanced number, and then we'll return it. Okay, return true. So idea is to identify the first smallest numerically balanced. Okay, so the moment we encounter the particular number which is actually balanced or beautiful, we have to straight away return it. Okay, in the end, this is the largest number for any given constraint. So this is the smallest possible beautiful integer after this 10 power 6. Okay, let's try to submit this problem. As you can see, the solution is pretty efficient in terms of both runtime complexity and in terms of memory complexity. Yeah, that's all about this problem. Do subscribe to my channel for more such coding videos. I will be posting on daily basis. I've noticed that most of the people are not subscribing. but still consuming my videos, I highly recommend you to subscribe so that you won't miss the content which I'm posting on daily basis. Yeah, that's all about this problem. Thank you.